Hey everyone, welcome back. Today I'm going to be continuing our exploration of Supertrend. If you'll remember in the previous videos, I began discussing the ATR or average true range, which is part of this indicator formula here. And we did it on paper, right? I did kind of a long drawn out explanation, but most people on this channel, you're not coming here to watch me do things on paper. You want to see it coded in Python. So I'm going to get started with that in this video. And so you see I have Supertrend here pulled up on a TradingView chart. I'll leave a link below in case you want to sign up for TradingView. So you see when you put the ATR and the Supertrend indicator on here, you see it draws this red line here, and you go short here, and then there'll be this green line indicating a buy signal. And you can see this green line is under here for a while, and it looks like for Ethereum here, at least on the daily, that was a pretty good signal to ride this trend and stay in it for a while, and then it eventually gave a sell signal right here. So let's talk about how to implement this indicator in Python, and I'm going to break this down into little pieces. I don't want the videos to be an hour long anymore. I'm going to try to do things with more frequency, where I release more videos, but spend less time, so maybe make them 15 minutes or so in total. So let's see if I can actually do that this time. So here it is. And the first thing you'll notice there's many different descriptions of this indicator. This is one that's written in AmiBroker, AFL, so there's some other language here. And you can see a text description of this formula here where you calculate a basic upper band and lower band, and that's using the high plus low divided by 2 plus some multiplier times the ATR, and then there's a lower band, and then there's this final upper band and lower band, and this Supertrend calculation. So what I want to do is break this down into digestible pieces, and we're going to write Python code to calculate at least this top part. And we're not going to use the indicator library. I want to just use Pandas data frame. So I want to get raw data, put in Pandas data frame, and then calculate all these values out using no libraries. And maybe someday in the future, you want to create your own custom indicator that's not in a library, or you want to add your own feature to your data set, then it's good to be proficient enough with Pandas to be able to do that without relying on extra libraries, okay? So if you'll notice here, like this is one basic Pine script example that I found. There's a bunch of these, and you see they all calculate this upper and lower band here, and so they didn't actually plot that here, but I'll just plot that here to show what that looks like. Okay, and so if I add that to the chart now, you'll see there's this extra, see these blue bands up top and down below. There's these bands, and you see this Supertrend indicator flipping from buy to sell. And so let's break down things piece by piece and even talk about the calculation of these bands here, these basic upper and lower bands. Okay, and before I dive right into Python, there are a couple housekeeping items. Number one, you may have noticed, as a few people alerted me on Twitter and other places, that they thought my account had been hacked, but my account hasn't been hacked. It's just there's these impersonator people out here that waste everyone's time, and so I had to delete like 100 of these comments and mark them as spam. If you see these, report them as spam, but obviously I'm never going to ask you for anything on WhatsApp or anything, or promise any great riches, but for some reason cryptocurrency and trading algorithm videos attract this type of content, and so I guess they ripped off my name, but my name will have like it'll be highlighted if it's actually me, and then I guess they take your profile picture as well, and they just change your display name. So no, my account wasn't hacked or anything, it's just impersonators, and it's just a waste of everyone's time, but that's how you've made it, right? When you have impersonators. So if you see those, just know it's not me. The second point I want to address is from this video I posted a couple days ago on the technical analysis library in Python. Todd Goulding pointed out, good catch, that there was actually values in the first row here. So if you look at upper band and lower band and moving average, you might wonder, how come this first bar has a moving average already when I was calculating these 20 period Bollinger Bands here? And one thing to note is that I was using an old version of Python TA that I installed long time ago, but there's new versions of it. And I guess the old behavior here is for the first 20 bars, instead of putting not a number like it did with the ATR, it actually took the average of the bars it had so far. And so if you zoom in here, even though this is the first bar, you'll notice the close is 1984.40. So for the moving average, it put 1984.40. And then for the second bar, the close is 1983.56. And the moving average is 1983.98. So if you look at that, what it looks like it did is it just added the first 2 bars and divided by 2, and then it added the first 3 bars and divided by 3, and so forth. So up to the 20th bar, it's just filling in with the average of what it already has. So weird behavior, but if you upgrade, and I upgraded my version of Python TA to a newer one, it just fills it in with not a number, which is what most libraries would do in this case. And I guess the lesson there is, number 1, upgrade your packages. And the second point is that I was comparing this to TAlib and said, this is probably better, or it looks better. However, a library like TAlib has been around a much longer time, right? And so these newer libraries, sometimes there's little kinks like that to work out where there's unexpected behavior. And number 3, I guess it proves my point of actually going through these calculations and understanding what you're looking for. That way things like that don't slip past you. So that's all the notes from the previous video. So let's go ahead and get started with translating this Supertrend algorithm here to Python. All right, I got a fresh folder created here, and I'm just going to create a file called supertrend.py, and we're going to get started. I'm going to import a couple of libraries we already have installed in the past couple of videos, and those libraries are ccxt and pandas, right? You should already have those, okay? And then what I'll do here is go ahead and get some price data. ccxt makes it very easy to get some price data. You can use Binance or Binance US. It doesn't matter, you don't need an API key for this data. You can use Coinbase Pro or Coinbase. I'll just use Binance US like that. All right, and then I'm gonna do bars equals exchange.fetch OHLCV, okay? And just like I showed in the ccxt video, we're just going to fetch some Ethereum data, and we can set a limit. So I'll just say limit equals 30. By default, I believe it'll get 500. So let's just run it by default and show what it gets. So I'll do for bar in bars, print the bar, and you'll see what it does. By default, it'll get some Ethereum price data. And I had a typo, OHSCV, okay? And then if I run that, you see I have a bunch of timestamps with open, high, low, close volume data, which looks good. And now I don't want that many bars, so I can do a limit. And that limit, I'll just do 30. And we have 30 bars now, right? And those are 1 minute time frame. And so what I can do is do a time frame equals. Okay, so by default, if I actually dove into this function, into the library itself, you see the default time frame is 1 minute. So I want to say the time frame is 15 minutes, right? And so if I run that now, so how do I get this date time to be more human readable? Well, I can say data frame, and I'll set the timestamp equal to pd.to date time, and I'll give it the timestamp column, and I just say the unit of the timestamp. So I'm going to do unit equals milliseconds. Sometimes you get the Unix timestamp in milliseconds, and sometimes you get it in seconds. And you see all these extra zeros, that means it's in milliseconds, okay? So I'll do that, and now if I print it, you'll see that, the 17th hour, 1645, 1630, and so you see how we have these 15-minute bars. If I didn't have this time frame and ran it, you'll see that we have it minute by minute, so 17, 10, 11, 12, 13, 14, and so forth, right? And so when I ran it there, you see that they're 15 minutes apart. So looking good so far, we got some good data to work with. All right, so we have a nice clean set of data here. So how do we actually go about calculating some of these bands and the average true range so that we can use them in this formula? So you see the basic upper band. So let's just leave a comment in our code and we'll know what we're translating. So we'll say basic upper band equals high plus low divided by 2. And this is just some pseudocode, and we'll translate this to Python, and we'll do plus some multiplier times ATR. And then here below, we'll do basic lower band equals high plus low divided by 2, and then it'll be a minus multiplier times ATR. So minus multiplier times ATR. So the first thing we need to do, let's go ahead and figure out how to calculate the ATR, which you'll remember is the average of the true range, which is TR. So let's calculate the true range first, and we'll append that onto this pandas data frame. So I know I could use the library. Let's see if we can calculate it on our own, and it shouldn't be too hard. So if we look back at the true range formula, right, the average true range here from Investopedia, you see the true range is the maximum of these three values, the high minus the low, the absolute value of the high minus the previous close, and the absolute value of the low minus the previous close. And we should have all those things, and so we should be able to write a function to calculate it. So how do we do that? So let's go ahead and get, you see how we have the current close here, right? But it's not very easy to compare this row with the previous row. So what I'm going to do is create a new column here called previous close, and shift these numbers down. That way we'll have the previous close right there next to the close. All right, so I'm going to do a df previous close equals df close dot shift 1. Okay, and let's see what that looks like. So if I print out the data frame now, you'll see that not only do we have the close here, but we also have the previous close. And the previous close is not a number on the first bar. And then if I look at the second close here, 217465, the previous close is 2167.21. And you see how that matches this this previous close right here. So we have the close and the previous close right next to each other, and that makes it really easy to compare them and subtract them in pandas. So I like having this separate downshifted column here that makes it really easy to do this calculation. So we have the previous close in a column, and so now let's do df high minus low. So I'm making a new column called high minus low here, right? So and you know, so there's no subtraction happening here. I'm just calling this column high minus low. You can call it whatever you want. And so I'm going to do df high minus low equals df high minus df low. Okay, and if I run that, you'll see I get a new column with high minus low. So we have the high is 2168.96 and the low is 2164.54. And if you subtract those, you have 442 in this high minus low column. Very easy. And then so now what else do we need? We need the absolute value of the high minus the previous close. Okay, so we'll do a df of high minus a previous close. I'll just call that PC equals the absolute value of the high minus the previous close. So df high minus df, and look at that, I have the previous close now, so that makes it very easy. So we'll just subtract the high and the previous close and put that all in this absolute value here. Okay, so I run that, and you see we have the high and the previous close. The first one is not a number, and so we have the high of 2174.66 here, and then we have the previous close right here. And if you subtract those two, you get this number 745. Looking pretty good. And then to polish it off, I'll do the absolute value of the low minus the previous close. So low minus PC equals the absolute value of df low minus df previous close. And then I'll have all of these things together, right? Low minus previous close, high minus previous close, and we're coming right along here. So looking pretty good. So now that we have these three values for high minus previous close, and low minus previous close, what is the true range? It's just the maximum of those. So how do we get the maximum of these three numbers, all the way down? So I want to compare high minus low, high minus previous close, and low minus previous close. How do I do that in pandas? Well, I can create a new value here called true range, and I can set that equal to my data frame. And what I need to do is pass it a list. So these are double brackets here. So I'm going to give it the list of my columns. So high minus low column, and I'll comma separate these, high minus PC, okay, and low PCs. So these are just a list of column names here, and I want to make sure there's only 2 brackets. Good. So, and then all I need to do is do max axis equals 1, and that'll compare these 3 columns together. And if I do the data frame true range equals this TR here, and then I run that, you'll see I have a true range column, and it should be the maximum of these 3 values. So high minus low is 16.6, this is 0.38, and this is 16.22, and so the true range is the maximum one. So the maximum one was the high minus the low. And if you go all the way down, a lot of times it's just going to be the high minus low, but you'll notice on this row here, high minus low is 658, and since high minus previous close was 768, the true range is 768. Okay, so we have the true range calculated all the way down. So instead of just writing this in a single script like this, let's break this down into pieces. It looks like we have a nice function to calculate true range. So why don't we just make a new function called true range here and have it accept a data frame as a parameter. And let's see if I can just write a function that just returns true range. And then we could call that from the average true range function. So I'm going to indent this out, and let's see. So let's say data frame true range equals tr df, okay, and then print the data frame, and let's see if this works as a function, okay. And looks like it's not quite right yet, so let's see what I'm missing. Oh, I need a return value. So I'm going to calculate the return value and return it from the function, okay. And then you see we have a nice true range function. So now we have a nice function for calculating true range on a data frame that has columns in this format of open, high, low, close, volume, and timestamp like that. So that's good to go. So let's create another function called the average true range. So now that we have true range, average true range is easy. So we just need to calculate the ATR. So going further, let's call a function called ATR, right? And we're just going to call this function, and that's going to calculate average true range. Okay, and let's see if that works. So I run that, and you see it says calculating average true range, and then it just prints the data frame, right? I don't have the true range in here yet, but we'll just have average true range call true range, right? TF, and so we'll say df ATR or dftr equals true range of the data frame. So when we call ATR data frame, we'll create a new column called TR, and then we'll call our true range function, pass it the data frame, and then now if I print the data frame inside here, you'll see that we have a nice simple data frame here with the true range, and then average true range can operate on this data frame that has true range already set. And so I should have everything I need in order to calculate the average true range. So I can just say the ATR or ATR equals data frame, the true range, and I'm going to do rolling, and you need to pass it the period that you're averaging. So rolling and then mean. So I'm going to just hard code the number 14 in there, and let's say df ATR equals the ATR and print the data frame again. Okay, so let's do that. And then look at that. So now we have a column called average true range. You can see we have not a number for the first 14, and then we have the average true range. So all it did was take the rolling mean, so of the previous 14, and then average those all together, and I got 10.84 here, and then for the next one it averages, the 14 below that, and so on and so forth. And we have this ATR calculation, which is part of our Supertrend, right? So we have Supertrend and this average true range here. So that's what's here at the bottom. Okay, so now that we have that, we don't actually want, if we're making a nice reusable function, we don't want to hard code the number 14 in there. So let's add a parameter called, let's say, period, and we can give it a default of 14, but when we call it here, we'll have the option of saying period equals, 5. So if we want the 5-period ATR, we can show it that way, and you can see now it starts calculating the ATR at the 5th row here, right? And so there we go. So now we have a function that has parameters, and it can calculate the average true range for whatever period we want to send in. All right, so how do we calculate these upper and lower bands now? So we went back. Did I already put a comment? Yeah, so I already have this comment here of the upper and lower bands. And so let's go ahead and calculate these, okay? So instead of, so let's go ahead and just return the ATR. So I'm gonna comment that out, and I'm gonna say the ATR equals that, and then I'm just gonna return the ATR like that, and then I'll create another function called Supertrend, okay? And that'll accept a data frame, and I suppose that'll accept a period as well. And so I'm gonna print calculating Supertrend, okay? And then this one we'll call ATR first. So I'll do df ATR equals ATR, the data frame, and I'll just pass it the period that came in, okay? And I'll print the data frame, okay? And so now instead of calling ATR directly, I'm gonna call Supertrend and give it some period, and then we'll put this comment inside of here, and we'll translate this to a basic upper and lower band. So I'm going to run this again. Okay, and yeah, so it's going to print calculating Supertrend, right? And then it's going to set the ATR, and it prints it out. Okay, so we're still have the same outcome. So let's go ahead and have this Supertrend function add this basic upper and lower band. So in here, we get an original copy or reference to the data frame and calculate the ATR. So now I'm going to say df basic upper band equals something, and df basic lower band equals something, okay? And so now if I do this, so the basic upper band is just the high plus the low. So we'll do df high plus df low, okay? And then we'll divide that whole thing by 2. So df high plus df low divided by 2. And then we'll do plus some multiplier. The multiplier is variable as well, so let's go ahead and have a multiplier variable here. So we'll do multiplier, or a multiplier parameter here, so that's customizable. And I can't remember, I think people use 3 and 7 as the defaults. And what's nice about this parameter is that we can change it later. So we're not going to hard code a value, so we'll do multiplier as a parameter. So we'll do multiplier times our average true range, which is already in our data frame. So that's df ATR, okay? And so here we'll pass some multiplier, or we can just leave it with the default. So I'll just pass it, I'll just call Supertrend with the data frame, let it use these defaults, and then we can override them if we want, okay? So basic upper band equals high plus low divided by 2 plus multiplier times df. Let me run that and print the outcome. Looks good, we have a basic upper band. All right, so if we drill in here, we can see we have the high plus the low divided by 2. So the high here, let's look at one of these items. So let's look at this bar right here. The high and the low here are 2165, 2157. So we got somewhere in the middle there, which would be like, what, 2161. And then we're going to add some multiplier of the ATR. So 3 times this 9.68, which is like 29 point something, right? So if we have 61 plus 29, that sounds about right, 2190. So it looks like we got a nice basic upper band there calculated. That's up, this is the one that's on top here. So we have the ATR, and then you multiply that times a value, and then you add to the average of the high and the low here, and you have this upper band up here that's following along. And then now we just need the basic lower band, which is the same thing. So we do this, but instead of adding this multiplier times ATR, right, we're subtracting it. So I'm just going to do minus. And there we go. So I run that, and we have the basic lower band. So 2190 above and 2130 below. The average of the high and the low divided by the average of the high and low, which high and low divided by 2 is like 2161, we said. So we add 29 and we have 2190. We subtract 9 and we have 2132. So yeah, that looks pretty good. And yeah, I think that's long enough for this video. I know you probably want me to continue, but I have these videos that are over an hour long and they take forever to edit and upload. So if I record just small pieces and upload them as I go, I'll have more frequent content, and you know, it's a more digestible piece here. Not everyone has 2 hours to watch a video and work through all of this. So I think that's pretty good. So instead of printing the data frame, I'll just return the data frame for now. And so I'll print, you know, a call to Supertrend like that, and leave that print out for now. And you see, it's not that much code. We wrote like less than 50 lines of code, 40 something lines of code. And that includes a comment here. Yeah, it's like 35 lines of code. So that's pretty good. No libraries. We fetched data from Binance here and started calculating this Supertrend. And we got the basic upper and lower band, and we calculated ATR and TR ourselves without any library. And so now all we got to do is figure out this other part here, this final upper and lower band, and the final Supertrend calculation to get these nice signals we're looking for. So we just did these upper and lower bands. Let's figure out how this green line and red line work in the next video. So thanks a lot for watching. Hope you learned something. See you in the next one.